Hello everybody! So in today's video we're going to be starting a new unit, and this unit is all about what's called graph sketching. Now when I say graph sketching, what that really means is analyzing a graph and looking at different features of the graph, and then sometimes being able to take the features of the graph and create a graph from that information. So it's a lot of vocabulary and sort of knowing how to look at graphs and look at equations in a different way. The first vocabulary word of this chapter is critical points. In calculus, critical points are the places where y prime, or the derivative of a function, is equal to 0, or the places where y prime, or the derivative of a function, is undefined. If you are asked to find the critical points, you have three options, which depends on your given information. So let's suppose for option 1 that you have f of x. When we say that you have f of x, what that means is you have an equation of a function, and the directions will say find the x coordinates of the critical points. So when we have the f of x function and we're looking for the critical points, what we need to do first is find the derivative, because the critical points are the places where the derivative is equal to 0 or the derivative is undefined. So step 1 would be find f prime of x. So in this problem, f prime of x would equal 8x to the third minus 8x. Now step number 2 here would be to figure out where f prime, or another name for that would be y prime, is equal to 0 or undefined. Now when I say equal to 0, what that means is that we are literally going to set this equation equal to 0 and solve. So step number 2 is to make the equation equal to 0 and to solve it. To solve an equation like this, I would factor out an 8x, and so I would get x squared minus 1. Then I would continue to factor, so I would have 8x parentheses x plus 1 parentheses x minus 1 equals 0, which means I would get 3 different x values, x equals 0, negative 1, or 1. So those would be the places, the x coordinates, where the derivative would equal to 0, which we found by taking the derivative and making it equal to 0. The third step, though, would be to look for where f prime of x is undefined. So if we go back to our equation for f prime of x, which is x cubed minus 8x, it's not going to be undefined anywhere, because this is a polynomial. If, however, when we took our derivative we had a fraction somewhere or a square root somewhere, then we might have values where we would be undefined. So that's when we would have additional answers. Because there were no places where our function's derivative was undefined, our final answer would be 0, negative 1, and 1. Because those are the 3 places where the derivative was equal to 0, and there were no additional places where the derivative was undefined. Now let's say instead of giving you the equation for f of x, in the problem they gave you the graph of f of x. If this is the graph of f of x, and we're looking for the places where y prime is equal to 0, or y prime is undefined, then let's take a second and review what it would look like on a graph if the derivative was 0 or undefined. In order for f prime to equal 0, we're looking for maximum and minimum places, because we know that the maximum and the minimum places are places where the tangent line would be horizontal, so the derivative would be 0. If we're looking for places where the derivative is undefined, that would be at corners, cusps, vertical tangents, or discontinuities. Since this graph doesn't have any of those, we wouldn't have to worry about that. Which means in this graph, the final answer would be at x equals -1, at x equals 0, and at x equals +1. Last but not least, if we're looking at the graph of f prime, so this time instead of giving me the graph of the original function, they gave me the graph of the derivative, then the places where f prime equals 0 would be the x-intercepts. Because in this graph, since it's already the derivative will equal 0 when the graph crosses through the x-axis. The difference here, of course, is that here we were looking at the original graph. So we were looking for where the slope of this graph equals 0, so we're looking for maxes and mins. Here we're looking at the derivative graph, so that would just be the x-intercepts, which means the final answer here would be x equals -1, x equals 0, and x equals +1. So that's our first vocabulary word, critical points, and we learned how to find the critical points whether we were given the original function, the original graph, or the derivative graph. Now let's take a look at our second vocabulary word for the day, increasing and decreasing. The reason we're talking about these words together is because they're kind of partners. They're both looking at the same things in a function or a graph. Increasing and decreasing are words that we use to describe slope. A function is increasing if it has a positive slope, which we sometimes call uphill. And a function is decreasing if it has a negative slope, which we sometimes call downhill. Now, whenever we're listing sections or intervals of a graph that are increasing or decreasing, we always use closed brackets for those. If you remember when we talked about position, velocity, and acceleration, and we said where is the velocity positive versus where is the velocity negative, we said a positive slope versus a negative slope, same thing. So option number 1, if you are given the function of f of x, and it says determine where the function is increasing and decreasing. Because the function is not what we're talking about, because we're looking at slope, we're going to look at the derivative of this function. So step number 1 would be to take the derivative of this function, which would be 8x cubed minus 8x. Now, in order to determine where the derivative is positive versus where the derivative is negative, we're going to start by making the derivative equal to 0. And we're going to solve. So we would factor out the 8x again, and we would get x squared minus 1. We would continue to factor, so I would have 8x, and then x plus 1, and then x minus 1. And then we would get x equals 0, -1, and 1. Now that we know where the derivative is 0, the third thing we're going to do is make a table. So in the table, because it doesn't say here that this function has a specific domain, we're going to start the table at -infinity, and then we're going to put in these values in order. So -1, 0, and 1, and then the end would be positive infinity. Now you may notice that this process looks very familiar. In position, velocity, and acceleration problems, when I gave you the position function and I said where are you moving right and where are you moving left, you would take the derivative, make it equal to 0, and make a table. This is the same thing. We're taking the derivative, we're making it equal to 0, and we're making a table, but instead of calling it right and left, we're calling it increasing and decreasing. Now in this table, we're going to look at the sign of f prime. So if I pick a number less than -1, like -10, and I plug it in to my factored function, we always want to plug into the factored version. Negative times 8 is negative, negative plus 1 is negative, negative minus 1 is negative. So I'm going to have 3 negatives in a row, which means I'm going to get a negative. That also means that the slope of my graph is going downhill for that section of the graph. Now between -1 and 0, like -1/2. -1/2 times 8 is negative. -1/2 plus 1 is positive. -1/2 minus 1 is negative. Since two negatives make a positive, this section of the graph would be going uphill. Between 0 and 1, for example, +1/2, I would plug it in and I would get a positive number, and a negative number. So I would get a negative here, and that section of the graph would be going downhill. And then bigger than 1 would be +10, positive, positive, negative. I'm sorry, positive, 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 which means they're all positive, so I'm going to go uphill again. Now, based on this table, I can say that my graph is increasing for the section of the graph between -1 and 0. So I would write -1, 0. Also for the section of the graph from 1 to infinity, and I'm going to use an open bracket on the infinity. That's the only time we ever make our brackets open. For decreasing, I would say between -infinity and -1. And then for decreasing, I would also say between 0 and 1, because that's where I got negative numbers. Now let's say you have the graph of f of x instead of the function. So when I give you the graph of f of x, it's actually a lot simpler, because we can tell whether our function is going uphill or downhill by just looking at the graph. So let's start with just looking for where our function is increasing. Our function is going to be increasing from here to here and from here to here. So my answer would be from -1 to 0, those are the x values where I'm increasing, and then from 1 to infinity, those are the x values where I'm increasing. For decreasing, I would just look for where my graph is going downhill. So this chunk and this chunk, which means I would say from -infinity to -1, and also from 0 to 1. You'll notice these answers are the same, and that's because this graph is actually the graph of this function. The f of x equals 2x to the fourth minus 4x squared. Now let's say you have the graph of f prime. We've actually talked a little bit about this before. We said that when you're looking at the graph of f prime, which is already the derivative, the increasing part of the graph will be the part of the graph that's above the x-axis. So this part of the graph and this part, because they're both above. So I would say between -1 and 0, and I would say between 1 and infinity. For the decreasing part of the graph, because this is already the graph of f prime, we would be looking at below, which in this part of the graph would be this guy and this guy. So I would say from -infinity to -1 and from 0 to 1. All right, that's all of our vocab for today. Critical points are where the derivative is 0 or undefined. Increasing and decreasing basically means uphill or downhill, but how you answer the questions depends on what information you're given. So let's take a look at some example problems. We're only going to do a few. So problem number 1, I'm going to give you f of x and ask you to find the critical points and increasing and decreasing. Because we know that both of these things have to do with the derivative, we're going to start by taking the derivative. So f prime of x would equal 3x squared minus 12x plus 9. And it specifically says on the interval between -1 and 5. Now, the second step would be to make your derivative equal to 0. Because critical points are where the derivative equals 0 or undefined. So if I factor out a 3, I get 3 parentheses x squared minus 4x plus 3. If I continue to factor, I get x minus 3 times x minus 1, which means when I solve this, I get x equals 3, 1. So my critical points would be x equals 3 and 1. And if there were any places where my derivative was undefined, I would just list them here also. However, because this is a polynomial, it's defined everywhere. It doesn't have any corners or anything. For step number 3, we're going to make a table. Because once I have the places where my derivative equals 0, I'm going to use these numbers and put them in a table. Now this time it did give me endpoints. So it said start your table at -1 and then put your numbers in order. So the 1 and the 3 would go in the middle, and then end your table at 5. We're going to look at the sign of f prime to put it into the table. And remember, we're always going to plug our numbers into our factored version of our equation. Between -1 and 1, I would choose the number 0. So if I plug the number 0 into here, the 3 is always positive. 0 minus 3 is negative. 0 minus 1 is negative. 2 negatives make a positive. I'm going uphill. Between 1 and 3, like for example the number 2, negative, positive, a negative and a positive makes a negative. I'm going downhill for that part of the graph. And then between 3 and 5, like 4, positive, positive, positive times a positive makes a positive. So I'm going uphill for that part of the graph. So if I were asked to list the intervals of increasing, I would be increasing here and here because both parts of the graph are going uphill. So I would say -1, 1, and then also 3, 5. If I were asked to list decreasing, so I'm looking for the parts of the graph that are going downhill, I would look at just this middle section, and I would have 1, 3. Now let's say instead of giving you the equation for f of x, I gave you the function's graph. So instead of the equation, I have the graph. Critical points are the places where y prime is equal to 0 or undefined. So we're looking for maxes and mins or corners, cusps, vertical tangents, etc. Based on this picture, I've got a min here and a max here. Based on this picture, I've also got a corner here and a corner here. So the critical points would be all of those places. X equals -3, x equals -1, x equals 2, and x equals 4. This would be a corner. This would be a corner. This would be a min. And this would be a max. If I were looking for where this graph is increasing or going uphill, I would choose this section of the graph and this section of the graph. So I would say from -3 to -1, and I'm going to make the -1 open because that's a place where the derivative does not exist because there's a corner. And then I would also say from 2 to 3, and I'm making the 2 open because, again, that's a place where the derivative does not exist because it's a corner. If I were looking for where I was going downhill, I would say this guy and this guy and this guy. 3 sections. So for decreasing, I would say -4, -3. I would say -1, 2. And again, I'm making those both open because those were corners, which the derivative does not exist. And then I would look at 4, 5, and those would both be closed. Last but not least, if I were to give you the graph of the derivative, so now this is the derivative, this isn't the original. If I said critical points, which are the places where y prime equals 0 or is undefined, I would look for the x-intercepts, this guy, and this guy. So I would say x equals -2, x equals 0, and x equals 2. If I were looking for intervals where I'm increasing, that would be where the graph is above the x-axis. So I would look at this guy, I would look at this guy, and I would look at this guy, which means I would say -3, -2, and now because this stays above, like it doesn't ever cut off, I can just list this as one big interval from 0 to 3. Lastly, if I was looking for the graph is decreasing, I would look for where the graph is below, which would be this chunk. And so I would say -2, 0 is that interval. Okay. Now that we've learned some vocabulary, we're going to stop and we're going to see you tomorrow and we will talk some more about this. Thank you so much for watching. Have a great afternoon.